There are certain things I want to discuss with you very quickly, and I need to do it in a hurry just so I can bring you up to speed. Some people have started the second exam, and it was still a work in progress, but it will be, now assigned. The second part of that exam, however, has certain things that I believe the students will need to know concerning something called joins. Now, previously we discussed union compatibility in two different data sets, usually tables. And the difference here is that joins are a bit more flexible, but they also have their drawbacks. So without further ado, I might as well just jump into what we need to talk about. One thing I want to do right off the bat, however, is I would like to be able to explain a few more things about some options that we have when we're using databases. All right, so I'm going to start a brand new console, and my H2 console will allow me to show you exactly, because I am actually using H2, the graphical web interface. I can show you a few things by illustration that will take place much faster than if I simply had to try and explain it from the command line. So let me just do that. And I'm going to basically get to the last of the tools that I will expect you to know. I know some people might be wondering, well, why? It feels a bit late, and I just wanted to round out a few concepts that I know that in practice would be good for all students to know. So my expectations won't go much farther than these last two concepts, which I'll explain very quickly. All right, so I'm going right back into my H2 database, and this is one of the many databases I've been working on for this semester, throughout the semester. If you take a look at what I have here, I have something that says information schema. I have parallel to users, that type of thing. You've seen in other exercises that I've done that there are various ways for me to put different relational variables into the database management system. So if you remember what a relvar is, it's basically the container for holding, or the structured containers that we use to hold data in our database management systems, or the subject of databases in general. All right, so just to recap, some of our examples were something called columns, tables, databases, data warehouses, and we also had one called views, which was kind of like a constant table, right? You could populate it with information. However, changing the data inside of it, you don't use things like an update command to set something to a new value. So instead, with views, what we did was we configured the view to be the type of container that would allow us to save the results of a given query. So if a query is very complex, we can use a view to take a snapshot of the outcome. All right. Now, between the database and table level, there's another relational variable, and this one's pretty cool. It's called the schema. All right. The schema in your databases, they're going to have certain attributes to them, and I'll just tell you what they are really quickly. So if I scroll back up to my commands here in H2, I'm going to use the create schema command. Here's what you should know. So the schema allows us to create a subsection or a partition of a database management warehouse system. A database management system within our database. So it's a substructure fitting under that database level. Take a look. Here I have the ability to create a schema, assuming it does not exist, and I give it a name, just like I would do with a table or a view. Now, here you have an authorization option. So the username can be a person who is allowed to use this schema. All right. Now, after that, we also have the following. This part is very important. You'll notice that it comes back to, or it comes into clear view when we use it with backing up our SQL files. The table engine parameter name. All right. the table engines are different depending on which database management system you use. So say we're using something like MySQL. MySQL has things like MyISAM. They have a few others, InnoDB, and so forth. Not every database management system is going to have the exact same data engines. So that's one reason why you need to be very careful about that. Now, if you notice what we have here, however, this particular part is just an optional parameter. And you can also have more than one engine that you're ready to store things with. Now, one way that we can or that we can, for our own part, try to keep in mind some very important details is to think about where our data may land. In the event that we have data that may need to be universalized, things like the character set, the engine parameters, they could come into clear view and start to show us where some of our decisions are going to be more profound than what we previously thought they would be. Here and there in H2's sample showing of create schema, they created a schema, test schema, that's the name of it. And then they also have something called authorization right there. And then they said SA. Remember that when you first got started with H2, there was an account called SA when we had the test database. All right. So that's how you use the owner username to validate that particular part of the authorization constraint, you might say. All right, so the owner username is actually going to be the name of a user. Now, let me just show you by example what we have. So if I want to do it in real time, I already created a schema, but I want to create another one. Here's how we do it with the H2. So I'm going to say the following: create, and let me just blow this up so that you can see much better. I'm going to say the following: create schema. All right, and the schema I'm going to create is called, I'm going to create one called parallel 3. All right, because I already created one called parallel 2, but I want to make sure that parallel is still within my options to create a schema. So now I have the name set up. I could use an authorization, but I don't really want to specify that. Instead, I will just create the schema, and then I'm going to show you how to use it. So basically, our database management system is going to believe that we're working within a particular context by default. Now, all I need is this particular part right here, this top level segment. And what happens is, if I just use that top level segment, that can be the minimal specification for me creating a new schema. So I'm just going to try and keep it simple. Create schema parallel, and I'm going to call it parallel 3, semicolon, and I'm going to run that command. So now my schema has been created at parallel 3. All right. Previously, you probably had one called public. You may have things like what we have here. This is what the database already includes. All right. So that's not for you to worry about. Now, if I wanted to then turn around and use the schema, here's what I'm going to have to do. I'm going to say set schema. All right, now if you're wondering where that command comes from, let me just show you. Moving up one. There we go. There's going to be a set command, and the set command actually allows you to make certain prerequisite specifications for what you're doing next. So let's just take a look. This is set right up here. All right. And notice how it's been classified as being outside of our DML or DLL type of settings. So now there's a lot of things that we can set, all right? However, in our personal case, what we want to set is the schema. So the schema is right there, set schema. Once I set the schema, I'm going to be able to automatically um, work within that schema. So this is kind of like changing your directory to move within a subfolder or subdirectory or a side-by-side directory. This is how we do it within our database management system. So now here they have schema string and schema name. Here's how you should understand it. The string is when you are quoting a particular schema. This is perfectly legitimate. It just says set schema according to a schema named public. But now if the schema name is quite obvious, or I should say very literal, we can just call it by its name outright, then that's the schema name option, which is what you see here in the second case. So now getting back to my console, I'm going to say that I want to set my schema as parallel 3. Now I'm going to highlight this particular part, and there you have it. All right, so now I'm working within parallel 3. So here's what I'm going to do. I'm going to set up a couple of new columns or a couple of new tables, and you're going to see parallel 3 start to populate. If you take a look at what I had here with parallel 2, all right, I already started to populate that with something else. Now, here's what I want to do. In short, there are a couple of files that we used for our previous database management system, and I'll just put things in a very practical sense. So I'm going to do the following. I'm going to use the actual SQL files that were expected for us to use in our exam 2. So let's just take a look at that together. All right, and now with that being taken a look, with us having taken a look at it, here is one of the 2 files that we need to use, and the other one that we need to use is called exam2update.sql. And so let me just highlight it for you guys. Just gonna search it out. All right, so exam2update.sql. This guy right here, so that's in my binaries folder. I have a second copy, however, it's elsewhere. That would be in my DBA folder, all right? So going back to my DBA folder, I can from here show you that it is not in one of the subfolders. It's very important that we remember to look for where things are, because if we do not remember, or if we can't find it, we may be embattled with trying to load these things into our database management system. So here's what I'm going to do. I'm going to say run script from, and I'm going to be using exam2update.sql. All right, let me put a semicolon there. Now that I've run selected, take a look. Parallel 3 was right here. All right. Parallel 2 is here. Okay. Now you're going to see what I have here says math majors and sci majors. All right. Now here is one thing that I may want to do. Let's take a look at exam2 update. So I'm opening up with my text editor. Now notice how they placed it where it says public math majors. All right. Public math majors means that what they did was they loaded it into my public section of my database management system. So that's why they put sci majors and math majors into this outer shell of a schema. All right. Now, if I want to make sure that that actually loads into my current schema, I'm going to have to re-express some of these different parameters. Notice how it says public.math majors. All right. The way we refer to some of these tables and databases, or I should say tables and other relational variables that are within a schema, is that we do it as follows. Here's the schema name dot the table name. All right, kind of like object-oriented programming. Another thing right here, schema name dot table name. So now, for the sake of the exam, let's suppose I wanted to like sanitize things and not actually I want to sanitize it and not actually place things blindly into a particular schema. Instead, I'm going to take out this part here that says public, and I'm just going to let the table name stand by itself. So as you can see, the devil's definitely in the details. And now with all these cases of public removed, just going to save this guy. And after having given it the once over, let's see what happens when I try that again. Remember, I'm in schema parallel 3. Going to hit run selected. And as you can see, now this guy expanded, parallel 3. There we go. So that's one thing we got to keep in mind. Now, I had also changed around the following. Customer overview, and invoice.sql. So as you can see, this one already has those particular parameters taken out. All right. So now I'm going to go back into my H2 interface, and I'm also going to run a second script, basically the customer overview invoice. All right. So and with that, I'm just going to run this command as well. And so now every file or every table that I'm referring to within the exam is loaded into parallel 3, just like that. So this is schema, and this is how we use them. There are a lot of other reasons why we may want to use schema. For instance, let's suppose that we have databases or tables, I should say, tables that are going to overlap with other tables. For instance, if a person has a standard by which other files are going to be populated, we may not have a choice in things such as how our taxes look on, a given year. All right. So from year to year, if we try to repopulate our database with these types of parameters, how taxes are paid, putting things in the exact same schema, or throwing tables in without any differentiation, we have only two options. One is that we could say by means of the table that there is a different type of year, but another one is if we know that we want to have multiple tables that will be nearly identical with the exact same classification of information, and we don't want to have what you might call namespace collision, like what we would have in C++ in Java, assuming that we don't use things like namespaces or packages. What we're going to want to do is to separate them apart by means of schema. If two people file for taxes separately, like a married couple, they decide not to file jointly, then you'll have two people filing for taxes using the very same parameters at the very same time in the same year, and the only thing that may differ is things such as the name and the actual working wages and tax situation that they had. So then for that particular year, if I'm going to be, say, a government official or a CPA, I may want to, and probably a lot for obvious reasons, many people will want to, it would be unthinkable not to, set things apart by having subcompartments in my database management system. All right, so then I'd be able to take the husband and the wife and put them into two separate tables and then hold their information in that those two separate tables, which are in the schema or separated by the schema. All right, so we could have like one schema called husband filing, the second schema called wife filing, and that's for the separate parts of their filings. Other things, let's suppose that in the world of biology, right, you may have different standards of taxonomy, so you may break things down based off of their perceived characteristics, and in the event that you find that from one year to the next, some of the characteristics are being redefined based on some scientific convention, we can kind of track the both of them using a schema. Another is if we overhaul our business, right? And we previously had one way of looking at customers or clients in our business, but we know that our business was overhauled to do things a bit differently, and now we collect different information. We can have a separate schema for a separate standard for how we look at account files. And when we do have that separate standard, what we can do is, have that difference in standard conveyed by way of a different schema. So we could actually have like the old backup copy and then the new, very relevant, useful current copy. And that would allow us to effectively rise to the occasion of that task and still move on with minimal damage done to our database filing systems, right? So now that I have those schemas set up and I've run those scripts, I'm good to go, right? I have everything I need for the second exam right there. Okay, so that is how we do things in this particular case, and it's good that we can, do this very quickly. You wouldn't want to have to necessarily try to, or I guess I should say, be mandated to reinvent the wheel. All right. Now, I should make it clear that these schema, they're very, very important for us to keep in mind. Take a look at parallel 2 and parallel 3. If I say select star for math majors, in my current schema, that's going to work just fine. All right, that's everything I needed. Now, if I set my schema to parallel 2 where it does not exist, I'm going to run this guy right here. All right, so now I've run that particular set schema. Look at what happens when I try math majors again. Nothing. Now, in order for me to fix that, I'm going to have to actually call it by name depending on where it's supposed to be. So I could say parallel 3 dot math majors, and there you have it. All right. So yeah, it's going to be very context detailed, you might say, or context oriented. What's good is that if I have multiple tables from various different schema, I can also do the following. I'm going to say select schema from parallel 3.math majors, except or minus select star from. And let's see, I use parallel 3, so I'm going to use public instead this time. Public dot math majors. And I should get an empty set for this. I don't think I updated it recently. So just like that, I'm going to highlight the both of them. Let's see what we get. So as you can see, there was no error, right? But I did get the empty set. That's because those were two tables that were completely identical. All right, so that's what I have in that particular case. So this is just one more thing for us to remember, right? The same way we can use table name dot column name, we can also use things such as schema name dot table name, and so forth. So there is a hierarchy to this type of thing, right? So that's the last of the relation of variables that I want to discuss, and I hope everybody sees how simple this is and also how useful it will be as well. So with that being said, thanks for listening. I'll have one more thing up to talk about joins, and goodbye for now.